Hello everybody, I'm Dan. Welcome to my Java tutorial series. All the source code for each video tutorial is located on my website at javacjava.com. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. This tutorial is on primitive numeric type conversion. I'm going to go and open up my website here, javacjava.com, and I'm going to hit the begin button. And this will take you to the list of the tutorials I've made. We're going to go down to data type conversions, click on that, and we're going to talk about the primitive numeric type conversions. In Java we can declare a variable any of the following numeric primitive data types. And I didn't include the Boolean on here because it's not a numeric type, but we've got byte, short, int, long, float, double, and char. Char is in fact numeric type, but it's a little of both. We'll won't go over that and argue that in this tutorial, but basically what we've got is these are the ranges for these data types, right? 0 to 6. So, and I didn't include the ranges for floats or doubles because that depends on how many decimals you have after the floating point, after the or how many integers you have after the decimal point, and so on and so forth there. So that's a whole nother discussion itself. But the only thing you need to know is that a float is 32-bit, which is the same size in memory as an int, and a double is 64-bit, which is the same size in memory as a long. Okay? You'll notice the char is a 16-bit, which is the same size in memory as a short, but the short can include negative numbers, so it technically has a range of the same exact memory size as the char. But this tutorial will focus on what happens when we assign the values of variables of different data types to each other. In order to simply assign the value of a variable of one data type to the variable of another data type, the receiving variable needs to be compatible. Now, to be compatible, generally the variable on the left of the assignment operator must be the same size or larger than the variable on the right. The char, float, and double data type variables do not adhere to this generalization, though. The following code will detail the process of what is technically called widening primitive conversions. There are 19 valid conversions, as you will see in the source code. My tutorial on primitive numeric type casting will discuss how you can assign values to incompatible data types. Okay? Let's go ahead and come down here to code, and let's scroll down here. I'll discuss all this code actually in Notepad there. We'll do Control-C to copy, or you could right-click and select to copy. Go ahead and move the browser off screen here. Let's go to Start, Search, type in CMD for our command prompt. If you're running Windows 7 or earlier, you can go to Start, Run, type in CMD. First thing you want to do when you do this, when you open up the command prompt, is type in javac and enter. If you don't see all this stuff scroll by, then you need to install the Java Development Kit properly. And you can do so by following my video for installing the Java Development Kit. Make sure you get it installed and configured properly. Go ahead and type in CLS to clear the screen. CD space / CD is short for change directory. / tells it to go down to the root. Type in MD for make directory, and then Java. I already have that folder, but if you didn't, it would go ahead and create it for you. I'm going to go ahead and do a CD Java, then make directory, type conversion, CD, type conversion, notepad, type conversion .java. Okay, type conversion.java is our source code file name, also known as a compilation unit. We're going to go ahead and create that. Hit Control-V to paste, or right-click and select paste. We're going to go up and save this here. Now what we've got is we're initializing a bunch of variables inside of our main method here. So we've got the data types I discussed up there: byte, short, char, int, long, float, and double. And it's pretty simple what I'm doing here. I got byte b equals 127, which happens to be the maximum value, and a b1 of 0, right? S maximum value for a short, C maximum value for a char, I maximum value for an int, and then the maximum value for a long. Float, this is fairly close to the maximum value, it's an approximation, and double, this is a fairly close approximation to its maximum value. Each one of these variables, of course, has like corresponding B10, S10, C10, and so on and so forth there, right? So what we're going to do is we're going to do the sections like long. Like, what can we assign to a long? As you know, a long is a 64-bit value, right? That's what a long can hold. So it can hold quite a bit. So we got this variable L1, which we initialized to 0. We're going to go ahead and L1 to the maximum value of an integer and see what prints out, right? We'll be able to assign the maximum value an integer into long because long is larger than it, right? And then same thing with a C, right? The character, same thing with the short and the byte. So because the int, the char, the short, and the byte are all smaller than the long data type, we can go ahead and assign them there. Now you might be going, okay, well what about the float and the double? Because the float is smaller. It's a 32-bit floating point value, and the double's a 64-bit floating point value. You know, the long is in memory. This is greater than the float, has just more memory, more bits than the float, and the double actually has the same amount. But now back in my tutorial, I was saying that the char and the double and the float don't necessarily adhere to those rules there, and you cannot assign, automatically assign, like say L1 equals F. It just doesn't work that way. Now you can do it sometimes the other way back, as we'll see in the float section there. So now in the int section, basically we know our integer value is a 32-bit integer value, and we can assign smaller stuff like a char, a short, and a byte, right? All of those values are smaller than the int. In the short section, we can assign a byte, okay? We cannot assign a char because a char, technically, even though they're both 16-bit numbers, the maximum value of a char is, when the positive range is 65,000, well, char has to be positive, 0 to 65,535. But a short, in its positive range, is 32,767. It can also be go all the way down to negative 32,768. So you cannot assign 65,535 into a short. So you can't do, the only thing that a short can be automatically assigned is a byte, okay? And of course I didn't even do a byte section because you can only assign a byte to a byte. It's the smallest of all of the primitive data types. Now let's talk about the double. The double here can pretty much take all of them, right? You can assign a long, right? And you can assign a float, because that's smaller. You can, well, the long is the same size, and the float is smaller, the integer is smaller, the char is smaller, the short is smaller, and the byte is smaller. So you can go ahead and assign all of them automatically to the double, okay? And then the float section here, the float is a 32-bit integer, so you can assign everything the same size or smaller. So you can assign an int, you can assign a char, you can assign a short, and you can assign a byte. Now, I did a couple of things here, and you'll see what they do because we get scientific notation on some of this stuff here. So, but let's go ahead and save this and run this. Let's clear our screen, type in javac for the Java compiler, and then type conversion.java, our compilation unit, and then Java type conversion. And this is what we get. So we come up here to our long section and we get our assignment from an int. Yep, that works. Assignment from a char, assignment from a short, assignment from a byte. That all works. And our int section, we can assign a char, a short, and a byte. Assignment from a byte in the short section, we get that. And assignment from a long, right? So what it does here in double is it goes ahead and uses scientific notation. And if you pay special attention to the scientific notation, you can see the numbers are all pretty much, if you drop this decimal point and squish them together, they're all pretty much good to go until you get over to 775807. This right here, they truncate it, like round it up and put the exponent 18 on there, the E18. So it's not entirely accurate here. So what I did is in the double section here, I did a type casting of long to force the print line method to display the actual proper value of the long to the console. And don't worry about it if you don't understand that, because I'm gonna do a whole nother tutorial on primitive type casting coming up shortly here. But that will kind of give you a little taste on that. Assignment from a float, assignment from an int, char, so on and so forth there. It uses exponential notation. sometimes, and sometimes it just goes ahead and does the decimal or the floating point representation with the decimal point and then the 0 on the end of that. And so float, we got our same thing. We can do an assignment from an int, and I did the same thing down on here where I did the type casting here. And we got our assignment from a char, assignment from a short, and assignment from a byte. So what I'm going to do up here is I briefly discuss that, you know, we've got an int, which we know is a 32-bit floating, or actually let's go down to the long. The long is the 64-bit non-floating point numeric number, right? And we cannot assign the double, which is the floating point 64-bit, to it. So let's go ahead and see what happens if we were to try that. I'm just going to type in enter here, and we're just going to say L1 equals D, right? Which is this double value. Right? Go ahead and save that. And what we're going to get is we're going to get an error when we try to compile it. And it's all just going to, it's going to specifically error out on this right here. So let's go ahead and compile it. And we get our error right there. Incompatible types, possible lossy conversion from double to long. So basically, all of this other stuff, we were just able to automatically do it, and it would automatically do, the technical term for that is of course what I discussed up there, widening primitive conversions. So those are the valid conversions that you can do, and in the next tutorial I'll talk about the other ones there. Let's go ahead and save this. Recompile. Off, run it again there. So we're back to normal there. All right, I'm going to go ahead and close out of this and close out of that. So just to leave you with some final thoughts here. As you can see, there are many assignment operations that are performed automatically based on the data type. Now, my tutorial on primitive numeric type casting will discuss how you can assign values to incompatible data types. That concludes this tutorial. Thanks for watching.